The following presentation was recorded at the 2025 Southeast Linuxfest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information on the Southeast Linuxfest, visit www.southeastlinuxfest.org. Come join us next June.
Hello, everyone. Welcome to Architecture Bootstrapping, an Enterprise Linux story. So, I normally when I give talks, I think most of us like tech talks and all that, but I firmly believe that every tech talk should come with a story, and the story should really not just talk about the excitement; it should be talking about the pain that you go through for anything that you do, right? And hopefully, I get to show everyone the mistakes that I made trying to bootstrap this architecture for Rocky Linux 10 and basically where we're going to go next and all that. So a little bit about me. I'm Abel. I'm one of the release engineering leads for Rocky Linux and also vice chair of the foundation. My day job isn't actually this. It's actually infrastructure and identity management. Some of the most boring stuff you can imagine, but it's my bread and butter. And then for Rocky Linux and RESF, this is exactly what I do on top of infrastructure. And then my hobbies, well, music, gaming, and I do a little bit of cosplaying too. And I won't show any pictures of it, but if y'all want to see it, just let me know. So to really get all this started, I have to kind of bring some things into context. Have to really show, have to explain, okay, what is RISC-V and what does it mean for not just this project, but also like the world. So we have to talk about first the difference between a primary and a secondary architecture. So if anyone is familiar with the Fedora project, we borrowed this concept from them. So a primary architecture would be anything that we support by default. So if you ever install our distribution, you're going to get 4 architectures that you can pick from. You can pick x86, you can pick ARM, you can pick Power, and you can pick mainframe, but I don't know why you would do this. You might as well just use RHEL at that point, but that's just me. The reason why they're called primaries is that if something breaks on one of them, it breaks for everybody. Like, we don't cherry pick, like they all have to succeed at once. That's a blessing and a curse, but it's just how it kind of really is. And again, they have to be all maintained and released together, right? So the success of 10 relied on all of our architectures to succeed all at once, right? The 4 primaries. A secondary architecture isn't in the same wheelhouse. So a secondary architecture is more or less like it's supported not directly by my team, but it's supported by some people on my team plus some fringe groups in the project, right? Cherry picking is allowed. If something fails, we'll work on it when we get to it. It's not going to block everybody else, right? Is basically what it boils down to. So RISC-V it's been around for quite a while, but RISC-V is a new architecture, and if anyone's come by our table, we actually have several little boards, and if anyone remembers like the original Raspberry Pis, that's how ARM, for the most part, people's exposure to it started, right? You have to start small to get big. And the reason why RISC-V is important is because it's not like ARM where you have to go through the ARM group for stuff. It's an open standard, right? It's got royalty-free licensing, and anyone can just basically get started. Like, they can look at the ISA, if they're interested in doing hardware development. I'm not personally. If you're interested in that, you can download the documentation and basically go from there for the most part. And the important part of it, this is not an all-inclusive list. I mean, it comes down to scalability. It comes down to, it really is an extensible thing, right? So you'll have variants of RISC-V, like not just the standard one. You'll have one that has what are they called? Like vector extensions and such like that. And I went to a RISC-V conference last fall with one of my colleagues, and the thing we realized is RISC-V is used in a lot more stuff that's not just computing. It was actually pretty wild to see all these different applications for RISC-V that don't happen to run Linux, which was kind of wild to me. And plus, too, like I was saying, lack of license feeds. You don't have to like pay to play, essentially. So the reason why it's important for the project is it gives our users, something to mess with. It gives them anything that they can put their mind to, right? Like if they want to mess with it, they want to come up with doing crazy stuff, maybe compile some weird kernel support that we don't have, like that's all the power to them. And I kind of look forward to seeing what happens out of that. And plus we have a couple of sponsors that expressed interest in it. And the energy efficiency part is, I think is pretty important, because my builders at home, the max wattage they use is like 12 watts when they're being maxed out and doing stuff. Like that's pretty power efficient. So that way I don't have to worry about maxing out my UPS and all that. So for Rocky Linux 10, when we released it just this Wednesday, we actually released it alongside all of our primaries, right? And if anyone buys a Vision 5.2, which you can actually go to Amazon and just buy it right now if you wanted to, it works immediately. You just flash it to an SD card if you're used to Raspberry Pis. It's the same idea. You just pop it in and you boot up. And then our special interest group for alternative architectures are going to work on a P550 vendor kernel to have a bunch of bells and whistles and all that. I'm staying hands off. I'm way too stretched thin to really like worry about stuff like that. And that's why I'm kind of mentioning Alt-Arch there, because we want to support other boards. Like there's the Banana Pi, and there's a bunch of other ones that are not coming to my mind. So this is where we talk about getting everything, how I got started, right? This is where the pain starts, because bootstrapping an architecture is not easy. And I knew that going into this, it wasn't going to be easy. And it reminded me of Rocky Linux 8, because we messed up at the beginning when we were building that and didn't have i686 for multilib. And I knew the pain I was going to go through. But this was a different type of pain that I decided to put myself through, right? And I'm saying there's always a better way, and you're going to see why. And you can go ahead and laugh, because I look back at it and I laugh at it too, because it was probably the dumbest thing I started off with. So to basically get a bootstrap started, if you already have a distribution you can start from. So in my case, I had Fedora 40 to start with. So I just needed some no-arch packages. What those are things that provide macros or provide build options and things that you generally need for the compiler to know what to do, to build the binaries, to build the libraries, right? And so that basically meant, okay, I needed all my Rocky release. I need my RPM Red Hat config. I need Red Hat RPM config. I need a bunch of macros packages, except for the systemd one, because for some reason, systemd and this no-arch package have a huge reliance on each other. And it bit me probably a couple dozen times every time this happened. And then again, use the Fedora RISC-V stuff that they already had as the starting point. And then because I didn't want to recompile the kernel, I didn't have NVMe. And because I didn't want to spend money, I didn't buy NVMe drives. So I used iSCSI for all the storage, because I didn't want to blow up the SD card, right? I think everyone knows, if anyone uses a Raspberry Pi and your SD card goes out, you know that pain, right? And a working mock configuration. And mock is the program that helps us build packages, right? So we're going to play a game of good, bad, worse. So this is what I mean by the pain, right? So good, you have storage you can use. So I had at the time, I had like a 4 terabyte RAID 10 that I could basically use for free, right? Well, free, but bad. It's on your router box and one of the drives are dying, which is true. One of my drives were dying, and I didn't find that out till like literally when I started this. Also good is I had a link aggregation. So I had a 4 gig pipe from the router to the rest of my network for bandwidth purposes. Also good, I have VLANs. I have a bunch of VLANs. Makes sense, right? Because I kept my builders on a completely different network. Bad. You didn't create a separate VLAN network for your storage. I had iSCSI running on the same VLAN as the Vision 5s. Never do that. Worse, you have iSCSI running on the same uplink that's dedicated for the entire line. This is how bad the architecture was. You can see my router on the very, very right. That's where all the storage was. All my builders are in the orange box, and they're all going through the same pipe. And imagine heavy writes happening, and you can't stream, you can't game, you can't. It's a horrible experience, right? Now I corrected this later, and I only corrected it after the first build that I ever did, which was for GCC. GCC is the C compiler. You need that to basically bootstrap everything to begin with. To put it into perspective, it took 7 days for this thing to build. It took 7 days to build GCC in one sitting. And I was already 2 days in, and then when my internet is getting crushed, I'm just like, I'm too stubborn to stop it and do it right. I'm like, you know what? I'm already 2 days in. What's another couple days? Well, it turned out to be a whole week. So I ended up correcting it. So the corrections I made was, okay, I have a big boy box where all my virtual machines are at anyway. Okay, I have another RAID 10. I'll just move all the stuff over there. Makes sense. I made a dedicated VLAN just for the storage. It can't touch the internet. And then I made sure I set up 10 gig fiber lines to make everybody happy. And that also meant dedicated Ethernet lines for everything, because my builders have 2 Ethernet ports. So, okay, yeah, makes sense, because everything else the way it was actually fine. And these are just mainly screenshots of like what my storage kind of looked like. Well, assuming the projector wants to work, but it's nothing too fancy. I just created some big volume groups, and I actually have 6 here, but the first 5 builders I had, and I gave them all like 110 gig disk, and divided everything up for the most part. So essentially, I was like, okay, well, I need to make sure I still don't touch the SD card. So I had to have a place where the sources can sit. I need a place where the build can happen, and I need a place where the cache can sit for mock. So I kind of just divided everything up, and everything was happy. At least in theory. No. There we go. This is a lot better, I think. Assuming the projector wants to show you all, but so you can see a dedicated line from the far left switch to the big boy box, right? And it is very much happier in this way. The moral of the story is, don't do the longest running possible build as your first one on the worst setup you could come up with. And that is easier said than done. But again, I realized this 2 days in, and then when it finished at the 7th, when I was watching the finishing touch, I'm like, please don't fail, because it was literally at the end, and then it worked. And I was like, thank you. Thank you so much. I can move on with my life. But when the whole thing was happening, when I was like, oh, great, I can't stream for like 5-10 minutes, this is how I felt. Just like every time it's like, oh, great, my internet's down. And my significant other knows exactly the pain. Of course, she never noticed. I'm the one that notices. Yeah. At least it's not SSHFS. And the only reason why I bring this up is because we currently can't have our Amazon EFS connected to our architectures that are not in Amazon. And anyone who deals with AWS knows that pain. And so we use SSHFS to do this. But I will say, though, for some reason, RISC-V, despite being slower than all the other architectures, it beat a mainframe in generating an ISO. I don't know why this is. I haven't quite figured it out. I don't understand it either. So we get to talk about crippling dependencies. And I got one person in this room that knows this plight. His name is Pablo. He's trying to hide himself, but yes. So order of operations. So for me to bootstrap, the order comes down to this. And the order is only because we got so used to doing builds and seeing how things interplay that it became really obvious, okay, what is the order in which things have to exist and have to build? So GCC comes first. Like I said, that took 7 days. And when I built glibc, that took an hour. That's a pretty big difference, right? And then we have to have Anobin, have to have elf tools, GDB, which is the debugger, strace make, and then we got to have OpenSSL, Golang, Perl, and then the kernel, the tool, LLVM toolset, and Rust. You can kind of tell from this, oh, you're making all the compilers ahead of time. That is correct. We need all the compilers first. And the other base libraries too, right? Now I say i686 PTSD because I brought this up. Trying to bootstrap that back about 4 years ago was hell in a handbasket simply because some dependencies either didn't exist or they had newer or older versions of things, and it's just you're taking a hammer to a screw when you really shouldn't be doing that, right? And I always ask this question, why do bad things happen to good IT people? Happens every single time. I ask this to my team once a week, every time something bad happens, and now the rest of my team asks the same questions to themselves every single day, right? But on the plus side, every time a problem came up, I was like, wait a second, I recognize this problem. How did I solve it? And not once did I write notes from 4 years ago to remember how I solved solved X problem. I guarantee you I wrote notes this time if we ever have to do this nonsense again. Because really, it does come down to historical knowledge. It's not just the order of operations, but it's like about checking, okay, did a package rebase? Is something lower or newer than what we need? Does our build root like not agree with this story? And were new dependencies added somewhere? And for some reason or another, there was a couple of times where I needed dependencies that not even CentOS Stream had. And it's like, great, here we go, right? So I bring up LLVM because this is when I actually had to really ask people for help. I needed a rubber ducky, right? 10 days of misery. Not 10 days to build, 10 days to even get the whole thing to build. LLVM is a combination of a bunch of stuff. We're talking a Python library, the LLVM libraries itself, Clang, and then accompanying libraries. And the worst part about this is LLVM and Clang need each other to build. How do you bootstrap that, right? So we're going in circles. And on top of that, I would get the first two done, which is LLVM and then Clang, and then I'd go to the next one and it would fail because it was like, oh, we're missing symbols. Well, what do you mean? They're like right there, and then come to find out, Fedora turns everything on, and then CentOS Stream like shrinks that down to like a small like chunk of things, right? In a spec file, this is what it would look like. The top highlighted is what they shrink it down to. The bottom one is what Fedora does. They compile everything. So no wonder there were symbols missing. But the question is like, okay, like, how do we get around this, right? This is how I felt because I was fighting this for 10 days trying to figure out how do I solve this. And meanwhile, I'm getting bent out of shape because I shouldn't be focusing on this so much, but I am. Like, I gotta make this work. If I don't make it work, I'm gonna go crazy. But the good news is, I ended up getting it to build. I just used GCC to bootstrap the whole thing. And it actually worked. I was actually quite surprised. But all I had to do is do a couple of things and then stop and then restart the whole thing again to rebuild itself. Because you can literally tell the build to use GCC. They use Clang. I just changed Clang to GCC and then everyone's happy, right? I bring up Rust, not because I had problems with it, but because it was the easiest bootstrap I ever did in my life. you need Rust to bootstrap itself. And that was it. I just pulled down the bootstrap and built the bootstrap, and then I used the bootstrap to build itself, and that was it. Rust was done. And that actually just took a whole day. And actually, the bootstrap was the part that took the longest, and then regular Rust took only like 4 hours. Wasn't too bad. Now I bring up System D not because it had problems, but because whoever wrote the spec file thought to themselves, we got to rely on a newer bin utility for RISC-V. The version that's in CentOS Stream 10 and Rel 10 is lower than the one that it was demanding. And I'm like, I'm not bringing in a new one. And so I just took the version requirement out and it worked. It's like, then what was even the point? So chapter 4 for patch-in support, I put a little sad face because it's true. I had to patch a lot of things. A lot of stuff works immediately. You could build Bash, it works. You build Corn Shell, it works. You build, GCC worked the first time, so I guess I'll use that as the example. But there was a lot of things I had to patch to even get it to work in the first place. So without reading the whole slide off, really what it comes down to is some packages wouldn't build because they didn't have RISC-V support, or they were the version lower than the one that brought the support in, and then eventually it rebased anyway. And then some just simply never had the support to begin with, so we're actually missing a couple of packages. And then there was some where it's oh well, it's we're at the end of the build, RPM will check for missing files, and it'll get to the end and be oh hey, you're missing these 3 files that you didn't list, so we're gonna fail. It's great. And glibc was the biggest offender of all of this, because for some reason, instead of using a lib64 directory, what does RISC-V do? It puts an LP64D. I don't know why you would do this. Imagine how I felt every time this happened. It happened consistently. I really wanted to throw my stuff out the window, every time. So this is where I finally tried to get it to boot. I spent about 4 months building everything for it to be self-sustainable, because I started this late August, and then around December is when I'm okay, I'm going to build an image. And I told my Altarch folks what I did. I literally used the truncate command. I used DNF to install into a directory and did a bunch of craziness to basically bring it all together, right? And so I plug it in to my Mac because I had QEMU. I'm okay, I'll use an emulator. And I'm watching to see if this thing will actually boot up. And sure enough, it did. It booted the first time. And I was actually quite surprised, because I have this mantra, which is, if something works the first time, what did you do wrong? Something is clearly broken because it worked the first time. But I was quite surprised to find out that it just worked. Even I was shocked, and I was so excited. And again, my significant other was just why are you so excited? And I'm you get so excited, you want to pet your animals, and your cats want nothing to do with you. And I'm just over the moon about this. Imagine everyone in the project watching this happen. It's literally how we all kind of felt about the whole thing, right? So pictures say 1,000 words, but mine says 5. What is wrong with you? So anyone who has a lab at home will know exactly what I'm about to tell you, which is your lab is only as clean as the last thing that you built. And I'm going to show these pictures so you can understand what I mean. So this is where everything happens. You can see the spaghetti wires. You can see the monstrosity of my wires. That's my standing desk. You don't see it, but I have a dual monitor KVM. It was worth the purchase, by the way. Having a dual monitor KVM was very worth the purchase. This is my P550, and it has actually reduced build times by about 50% compared to my original builders. That's a huge... what's the thing on the right? Oh, that's my mic stand. Oh yeah, oh you mean the left? Yeah, that's the power supply. Don't even judge. And then of course all the wires from my Vision 5s, the red cable is the internet, the blue cable is the storage, and they are still using iSCSI to this day. And this is the big boy box. Look how clean it is. This was the last thing I built, so of course it's cleaner than everything else. And like I said, your lab is only as clean as the last big thing that you built. Am I ever going to clean it up? Probably not. And I'm sure all of you understand that too, because we say, yeah, I'm going to clean this up. And what did we do? We don't do it at all. That is correct. So we're going to talk a little bit about the future of like what's coming down the pipe for at least RISC-V for the project and the project itself, right? So right now we're spending a little bit of time building a new version of our Peridot build system that we got all built up about I think it was like 3 years ago or so. That's kind of like an important deal because there's a lot of cool things we want to do, and what we have now just isn't cutting it. And plus, we want to make sure that it actually does have RISC-V support out of the box and all that kind of fun stuff. We also want to support more RISC-V boards. So if there's folks out there that find a board that our kernel doesn't support, which is very likely, just come hang out with our AltArch folks and we'll build something. We'll make something happen, right? And so we're also planning on moving from GitLab to ForgeJo. If anyone doesn't know what ForgeJo is, it's actually a hard fork of Gitee after some like open source license nonsense that was going on with that. It was like a combination of license / I guess money talks. I can't remember all the details, but we're trying to make a big move for that, because to be quite honest, GitLab is a hog, and myself and the rest of infrastructure are tired of hosting it. Like, we can't update it right now because the configuration says, oh, you need to migrate this. Like, okay, cool. And then you migrate it and then the whole thing breaks. So it's like, okay, what was even the point of going through that? We're also working on boot C images. They're bootable containers. It's been commonly requested for the past year. I don't know how it works. I'm not the one that's going to be building it. That is something someone else on my team is fighting with right now. I want nothing to do with it. I got other things to deal with, like RISC-V, right? I got other things to deal with. So what's kind of next is like upstream enablement. So I know right now, if I remember correctly, Red Hat put out like their developer preview that runs on P550 or something like that. I personally have not looked at it. I don't know what it contains or what it's about. But really, it's not just for CentOS Stream, but it's also for Fedora. It's still a secondary architecture. I think they recently moved their build systems and trying to make things a little bit easier to develop for Fedora, which is good. Plus, we want some more stronger hardware, and it's not just for RISC-V. Like, we want to enable the future of Rocky Linux. Like, some of our builders are a little on the slow side, and I mean, I guess you can't really argue with free, but we still need to figure out how to make that a little bit better. For context, the memory is so low on some of these machines that we have to enable a swap file for Firefox to build. I know that sounds ridiculous, but it's true, and I want to blame Rust for this because Firefox and Thunderbird, a large part of their code base is in Rust, and it'll get 75% of the way through and be like, oh, we're out of memory. Well, too bad, too sad. And that's, oh yeah, that's true. Don't mmap 12 terabytes of RAM that you do not have. So, so I'm saying send help because of course I'm the primary person who built RISC-V from essentially not the ground up per se, but for the most part from the ground up. 98% of it was done by me. The other 2% was asking for help from other folks to look at a failure and be like, what do you think? Because I don't see anything. Or sometimes the Fedora folks have a patch that I don't have to go rummaging for. And then some things I've had to like come up with a patch by myself. And I've asked one of my colleagues to come up with something, or he took the liberty to patch QEMU to make it work for for 10.0. I don't know how he did it, but he made it work. And then I can't speak for the Fedora project or CentOS Stream, but the Fedora folks that are working on it, and I know the CentOS Stream folks, when they get there, the ISA SIG, I think they would appreciate any help that like comes their way for sure. So definitely, don't just help us, but help everyone else out. Because at the end of the day, if we help out Fedora, it helps everybody out at the end of the day, which that's just a fact of life. Thank you very much. So we got a bit of time. So I just wanted to leave this open for questions, and it could be about RISC-V, the pain that I went through. It could be about the project. It could be about anything. Keep it within reason, of course, if you're going to ask about me directly, which I just asked, What's your comment? The angry page? Which angry one? What? Me throwing the monitor out the window? Is that the one? Let's see if I can find. Oh, y'all, this one? Okay, one of my teammates is saying this is my natural state at all times, which I can't. I have a hard time disagreeing. I can't fight this. I can't fight this at all. That is true, but also, to be fair, when something works, we just passed it, right? Right. When something works, this is how I feel, right? And everyone knows. Yes. Okay, to run Crisis. Oh my goodness. Maybe. People have made Doom already work on it, so I mean, sure enough, right? Sure. What's that? Oh, that's gonna be your next question. Yeah. 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 I'll build my own spec files for like my own packages. I actually had. So the question was, okay, have I gone and like built things by source by hand before and done all that? I actually have. Like back when I was much younger, I messed with Gentoo. I mean, of course, everyone's got to mess with that once, right? You mean have I resorted to that? I actually have. Yes, I have resorted to having to do something by hand. We actually had to do that. I actually remember this. That was something Pablo had to help with, because we actually had to compile Rust by hand first and use that as the bootstrap, because for some reason, we couldn't bootstrap it the normal way. And it was, I remember that. It was such a painful ordeal. So so I've had to do it before. I mean, I don't wish it upon anybody. But thankfully for RISC-V, I didn't have to do that. Like, a lot of that was already taken care of, and upstream meaning like Rust, right? Like, they already had the bootstraps and all that stuff that I didn't have to like do any fighting or any of that with that. That's a very good question. We had to do it before. I'm not really sure about that.
Not throw away, but put it aside for a minute so that you can create something so that you can go back and do the real thing.
Yeah. You got to do something on the side, then use that to build the real thing. And depending on who you ask or talk to, some people call that like sometimes you have to resort to cross compiling and doing a bunch of other craziness, right? I've never had to cross compile myself. And I'm sure that is additional pain I do not want in my life, right? Doing this was painful already. I don't need to I don't need to cross compile. But we actually talking about cross compiling. That was something that some folks in the project have actually asked. Like, well, why don't you just do cross compiling to help do these builds? It's like, okay, but then we're gonna have to rebuild it again anyway. So why not just do it the way we're currently doing it, and it's for the most part works, right? It's, I mean, that's just me. I mean, personally. Well, another question actually came up. That actually brings up another one. One of my teammates actually said, well, why don't we just build in QEMU for emulation? It's slower than the Vision 5. So that's a unfortunate hard pass. Otherwise, I would have done it. But like you can give the thing like every processor core that your box has, and it is still slower than a Vision 5. And I don't know why. I guess it's just because it's emulation. I don't really know. I'm a little blind when it comes to that stuff, personally. So far, it feels stable. Yeah, we have it all built. It feels stable, and that those screenshots I showed of like it booting up, right? I still have that VM on here to update it and double check, like, oh, are you still working? Are you still operating normally? If I do a DNF update, does it still work? And so far, it's been working fine. And the few folks in our project who have installed to their Vision 5s or even in QEMU haven't reported anything to us yet. But if something does go wrong, we get to play the investigation game, which I'm looking forward to. Yes, sir. Oh, yeah. Are we going back to the 90s? Yeah, so right, yeah. Like, like it makes me think of Raspberry Pis. Like they don't have they don't have like a firmware built, or not a firmware, but like some kind of built-in mechanism, right? Yeah, so I don't know. Yeah, yeah. Well, I mean, at least, but to answer the question though, I don't know where the bootloader stuff is going to go with RISC-V, but I know with what we currently have, at least for the Vision 5.2 and the P550 that I have, like you can turn those things on, and you'll get something that'll pop up. Will it boot? Probably not, because you don't have anything like plugged into it. But I did notice that at least on my Vision 5.2, it boots with UEFI. Like as long as you set up the SD card correct, you have to have a U-boot thing. You have to have a device tree partition with the stuff on it. I mean, it's not complicated, but UEFI is like the thing that actually does come up. Yeah, that's ACPI and all that. That's a whole other can of worms. I thought about that too. I've actually thought about that regression too, to be honest. I'm like, please don't do this, but what Skip, come on. Can we get to him? Oh, what kind of workloads? Well, the only ones I'm doing is building our packages. That's that's probably the only workload that we really got going. And like I was saying, it's like when we're building the big packages, that takes up so much time and it uses every resource that these things have. And GCC isn't the only one. I mean, if anyone knows about the KDE desktop, right? It's built on Qt. The Qt6 base takes like a whole 24 hours to build on RISC-V, and it is so agonizing. Yeah, I guess it is kind of back in the 90s. But to be fair, the hardware is going to it'll eventually catch up. But maybe I'm being idealistic. I kind of hope that maybe like they won't fall into the same traps or the same problems that the ARM folks created on themselves. Like, what's that? They're usually CPU bottlenecked, yeah. And really like my Vision 5s, I think their frequency is like what 1.4 gigahertz or something like that. And then the P550s are just a tad bit higher, but for I'm not sure I'm not sure why or how, because I'm not a hardware person. Again, they cut down like my builds by half. So and it's the same number of cores too. So I don't know. Again, I'm not. What's that? Surely we can keep doubling. I mean, yeah, that'll solve everything.
Search code is mostly CPU output, and then when you start linking, everything it's able because you have to go back and forth with this and understand and all the object files and everything.
Yeah, Bill. Yeah, you start getting to the whole linking and all that stuff, and 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 what even sucks even more is I mean, I don't expect anyone to do this unless they're crazy like I am. Since we don't have HDMI support like on the Vision 5s, like the base kernel doesn't support it. But if someone builds the vendor kernel to get that support and they want a desktop, you're not going to get a browser because I have not been able to get Firefox and Thunderbird to build. Take a guess why. And it's not the CPU. It's memory, it's RAM, yes. And it fails in the same spot that it fails on our other builders when they're like, when they run out of memory, got to use a swap file. Dude, please don't put horrible ideas in my head. I might do it. Send me some NVMe drives, please. What's it? Oh, just do it one core at a time? Oh, goodness. Yeah, get me off iSCSI first. I don't got months. I don't got months to build this Rust application, man. I wish I did. Oh, jeez. I mean, W3M, either Lynx or W3M as your text browser or something, I guess. Oh, what's that? Or just use curl. Yeah, just get the whole thing in the way that it was written. Go through that pain. Yeah. Well, maybe maybe the internet was a mistake. Neil just said something that's important. This is what happens when you teach Sand how to think, or do math, or do arithmetic. This is exactly what happens. We get into this situation. So if we have no other questions, all right, I think we're good. Thank you, everybody.